Welcome to episode 39. We're going to use a future today, and that's going to come from Ramda-fantasy, and of course we have Ramda. And then because RunKit's actually more of a node service kind of thing rather than like a front end, we're going to use got rather than fetch. But on the front end, this would work. This is just what we're using for an AJAX call. And so what we're going to do today is to show an example of retrieving the ISS location. And so let's get right in. So the first thing that we're going to do, because what got is going to return for us is a promise. And if you're used to only ever seeing the node style continuation passing where you've got callback style everywhere, promises seem really cool. But the problem is that they really are a really poor abstraction. Nothing forces you to call then. Nothing forces you to catch. You're not explicitly having to deal with the fact that whatever we're doing is asynchronous, probably out of bounds, and there's a decent chance that it's going to fail. So what we would prefer to do is to use a future. And in this case, what we want to do is we want to take the got, which is just coming from require got here, and we're just going to wrap that up. So we're going to create a new function called getF. That getF takes one argument, which is a URL, and it returns a future. You know this because it's the first thing after our fat arrow here. So we're going to return a future, and that future, what you pass the future is a function of arity2. And basically that just means a function that accepts two arguments. A reject and a resolve. So if you've done anything with promises at all, this is going to look very, very similar from that standpoint. So what we're going to do is we're basically going to unwrap the promise of this got, and we're going to return a future. So whenever you have something like that, this is very similar to something called a natural transformation. We're going to transform a promise of some type into a future of that same type. So basically we're going to call got on the URL, which is going to return a promise, and on the then we're going to take that value, we're going to resolve it, and basically this is just dealing with, this bit in here is just dealing with the way that got returns the data. So it gives us a response that has a body which is all text, and we just want to parse that because in this case we're getting JSON. And then we want to catch it because we want to be able to reject that future. If something happened in all of this, we want to be able to reject that future. And by doing it this way, this is the only place in our application now, or we're dealing with this, that we have to be aware, that we have to be aware that we're not being forced to do anything. We have to have diligence here. But this is the only place now that we have to have that diligence. So now what can we do? So we can call result, and that result is going to be a getF, and so that's going to be whatever we get from this. But what we'll notice here is that result is a future. So without calling fork on it, this is all lazy. This is the additional benefit. In addition to being more correct and more explicit and removing developer diligence, that you would have to have with a promise or an observable, because observable does the same kind of thing. You don't have to catch errors with observables. With a future here, what we're saying is that we have removed that diligence, because when we call fork to actually execute it, we have to explicitly provide something for the error and for the success cases of it. But this future, the additional benefit on top of all of that other stuff is that it's lazy. What that means is that it's not, when I call getF here, it's not actually going to go off and do anything. What that means is that we can build up whole chains of what will happen whenever we choose to actually execute or to go perform this side effect thing. And that's what happens when we call fork. In this case, you see them like right on top of each other in different lines. In actuality, in your application, this is a way to let you to bubble up this type, so that when you look at the type of your entire application, if it does anything with going off and performing and uses this getUp function anywhere in it, you'll see at your application level that your application returns some sort of a future. So that's a way to look at it, and I've got another post on what's in a type that I explain some more of that kind of stuff. So we're going to fork, we're going to provide our error case, we're going to provide our success case here, and in this case we're just console logging whatever the success case is. And so if we run this now, then what we see is that we get this object back here. It's got an ISS position, and it's got a message that we were success and a timestamp. That's basically the raw thing from here. But what if all we needed to know was the ISS position? Well, here's something that's really, really neat that we can do. Future is a functor, so we can map here. So result here still does not go off and do anything. It's building up a computation for what will happen when we fork the future. So we can hit this again, and now we've mapped to the prop is just the ISS position, and now we have just the ISS position returned. So what we say is that in this case, this result now is probably a poor name because it's a future. It's not a result. But now it is a future of a latitude longitude rather than a future of whatever is returned from here. We're still not going off and getting anything until we call this fork here to be able to do with whatever. This undefined here is just because fork returns unit or undefined basically. So that's what this undefined is. So we can look at it there, and there you have it. That's the current ISS position as of whenever I am recording this. So the benefits again of a future, using a future over a promise or anything else. One, it's going to be explicit. It's going to force us to handle the error case to also handle the success case. If you've seen pattern matching, that's basically what we're doing here. It's not a full featured pattern match, but the fact that it's requiring exhaustive matching is a benefit. There's no way that you could possibly forget to provide basically the catch portion from a promise here, because fork has to accept two arguments. And the other cool thing that I actually like about it a lot is that the error case is the first one. So because JavaScript, you could pass it one argument and not provide the second one. If the success case were the first one, then you could just basically forget to provide the second one, and you could essentially hide the fact that there was potentially an error case. But because error is the first one and the success is the second one, there's no shortcutting that or whatever you're forced to do with that. And then secondly, it's lazy. And by that I mean it does not actually do anything until we call fork. That means we can use our functors and our monads and our applicatives and everything, which future is all of those things, to be able to build up our computations and move forward from there. So anyway, a little bit of a longer episode today for not a whole lot of code, but play around with this, see what you think, and let me know what you think.